Hello students. So again welcome you all in this fourth lecture. Now here in this fourth lecture we will discuss about Rankine cycle, but condition is superheated condition. Clear? So I am sharing this PPT with you. So 1 minute. Okay. Now I hope that you are able to see this PPT. So let us do it in a full screen. Okay. So in this example, we will solve one numerical, but before that we will just understand that what is superheating condition. So here you can see that today we are going to discuss about this cycle 1a, 2 double dash, 3 double dash, 4 and 1. So this cycle we will discuss today. So here, but just for the simplicity, here we will not consider that 2 dash, we will tell it as a 2 and we will tell it as a 3 for our example. Clear? So this is basically known as superheating condition. So at point 2 we all know that our water totally converted into steam. At point 2 our water converted into steam, but if we will continuously, or if we will continue our heat supply after that conversion, then temperature again increase and our point becomes 2 dash, 2 double dash. Clear? So this is basically that cycle, superheating condition. So here also you have to use, or you have to find out all the enthalpy H1, H2, H3 and H4. Now here, first of all, we will take the overview that in this slide, which are the content. So here, this is the formula for H2, formula for H4, formula for H1, for H3. Procedure is lengthy, but it is for the H3. This is the data for example. This is the table. These are the solved problem. So one by one, we will discuss each and everything. So in last time I told you that if our point is here, so then equation will be HF at boiler pressure. If our point is here, then our equation will be HG for boiler pressure. If our point is in between, then our equation will be HF plus X HFG. Clear? And if our point is outside of this dome, at that time our equation will become Hg plus Cps. Remember this, Hg plus Cps in bracket T superheated minus T saturated. Remember this. This is the general formula that if our point is here, HF is in between HF plus X HFG, if here Hg, if outside Hg plus Cps T superheated minus T saturated. I am talking about the enthalpy only. For entropy also different formulas are there for entropy. Now suppose we will talk about the condenser pressure. So if our point is here, then HF. If in between, then HF plus X HFG. If outside, Hg plus Cps, in bracket T superheated minus T saturated. So these are the general information. Now we will talk about the entropy. So here it is not necessary to remember the formula. Clear? If our entropy is here, so sf. If entropy for here sg. Right now we are talking about boiler pressure. Is if our point is in between sf plus x sfg, and if point is outside of this dome, then our formula will be sg plus cps ln Lagrange T superheated divided by T saturated. Clear? So I am just clearing your doubt that these formulas are simple to remember. Just you should know the basic. Clear? So these are the formula. This is formula for h2, for h4, for h1, and for h3. So this is the data. For example, so which are the pressure? 30 bar, 0.09 bar. What is the temperature? Here temperature 350 is given, and this is our 2 kg. Clear? So first we will understand the table of taken from the steam table. So here you can see, so at 30 bar we have a saturation pressure this 233.8. At this pressure we have saturation temperature 43.8, but temperature given is 350. In data we read that our temperature is 350, so it is basically higher than 233.8. So we can estimate that our condition is superheated. How can we make confirm that our condition is superheated or not? If this temperature is higher, if this temperature is higher than this temperature, obviously we can tell that our condition is superheated. I hope that you have understood it. Now we will focus on the uh, enthalpy. So first we will find out the h4. So simple, what is the formula for h4? H4 is equal to hf at p condenser. So you have to take it from the p condenser. So this is our p condenser, this is p condenser. What is hf? 183.3. 183.3. So here you can see, just simply we put the value from the table. So now for h1, first of all you have to find out the wp. So vf minus p boiler minus vf p boiler minus p condenser. So 30 bar, so here 3000, and 0.09, so 9. Here vf taken from the table, you can see that vf is taken from the table. So this is the answer we got. Now we know that wp is h1 minus h4. So h4 we already know, so we can find out the value of h1. So two enthalpy we found, h4 and h1. Now for the h2, so I hope that it up till now it is clear to everyone, h4 and h1. Now for h2, here you can see, for h2 hg plus cps t superheated minus t saturated. All the data you have to take from the boiler pressure. So hg taken from the boiler pressure. Now these you have to remember. cps 2.1 kilojoule per kg kelvin, always you have to remember. T superheated T 350, that we know, and T saturated 233.8. So from where it is taken? Here you can see 233.8. So it is taken from here. So this is how you can find out the value h2. This is how you can find out h2. Now for h3, procedure is lengthy. As I told you in last lecture also, what you have to do? You have to first find out the s2, then you have to find out the s3, then you have to find out the x3, and after x3 you have to find out the h3. So this is the procedure to find out the h3. So in this data you can see, first of all we found out the s2. put all the data. Now here it is necessary that you have to take it in Kelvin. So it was basically 350, so we converted that 350 into Kelvin. So 350 plus 273, so this is in Kelvin, this is in Kelvin. So put all the value here, so we got this S2. Now S3 is equal to S2. Then these you have to compare, these S3 you have to compare with the SG, with the SG. Which SG? SG at the condenser pressure. So what is the SG at condenser pressure? So this is the SG at condenser pressure, and our answer was 6. So we can understand that by use of this. Now here you can see, suppose this is the SG at condenser pressure and it was 8, and what answer we got for S3? It was around 6. So basically it is less than this SG. This is basically less than SG. That's why we can apply the formula that we have used in this example. Basically three cases are there. Either our S3 may be less than SG, so this is first case. Either our S3 may be equal to SG, or S3 may be higher than SG. So all the possibilities are there, but in general, in our case, in our subject, always we will have this condition. Always we will have this condition in our chapter, in our subject. So this is the only condition that we have mentioned in our numerical. I hope that you have understood this properly. Clear? So that's why these two enthalpy we found. We also found the H2, and then also we found S3. We have compared that S3 with SG, so we make sure that this S3 is less than SG. That's why we can apply this formula. We can apply this formula. We have to find out the X3 from this formula. Now from X3 you have to keep it in this formula, and you can find out the H3. I hope that I am not going in detail about the all the value, because these already we discussed so many times. So this time I am not discussing it in detail. Clear? But here, then after we can find out the efficiency. Now efficiency, you all know what is efficiency. WT minus WP divided by heat supplied. So this is basically WT, WP. So just put all the value of enthalpy and you can find out the efficiency. Clear? Then this was the case that we discussed. If S3 is less than SG, find use this formula, find X3, put that X3 here and find out H3. This is our case number 1. Clear? So always generally, so this is basically wrong. This is our case number 1. This is our case number 2. For case number 2, it is very easy to find out H3. Just H3 is equal to Hg at P condenser. Simple. You do not have to complete this procedure. Only simple formula, H3 is equal to Hg at P condenser if these conditions satisfied. Clear? So this is basically not part of our example. In example we have used this, but this we are discussing that 3 types are there. So this is our third type. Here you can see third type. So in third type, first of all you have to find out the uh, S2. Then after S2 you have to find out the S3. Then S3 you have to compare with the SG. If S3 is higher than SG, use this formula, find out this. Clear? So once you found out this, put that value here, put this value here, and you can find out the H3. So this is how we can solve all the numerical. So I think that I know that it is difficult to understand, but what you have to do, you have to just do the practice along with this video. Then it will become clear to you. Clear? Again, I am repeating what we did. So we discussed about the superheating condition. Then these are the formula H2, H4, H1, and H3. But as I mentioned here, this is the formula only for this condition. Only for this condition. If this condition satisfied, then only you have to use this formula. Otherwise, not. Clear? But in most of the case, we have this type of this condition satisfied. So always at that time we have to use this formula. So these are the formula. This is the data. This is the table. Then we solve all the numerical. First we found out H4, then we found out H1, then we found out H2. Then for H3 procedure is lengthy. We found out S2. S2 is equal to S3. We compared it with SG. We found it is less. So we utilize this formula. We found out X3. Put that value in the here. Found out the H3. So this is how we found out all the enthalpy. And then after efficiency, just put all the value of enthalpy. So this is the condition. Our condition first. This is basically wrong. This is our condition 2. So if this is condition 2, condition 1, condition 2, and if this third condition, at that time you have to use this formula, that find out S2 first, S then from S to S3. If S3 greater than SG, use this formula and find out this find out this, put this value and find out H3. I hope that you have understood whole procedure properly. So thank you for listening me. In case of any doubt, you can contact me anytime. Clear? So here I am stopping this video. Thank you.